Hello everyone, this is Miss Spivey. Today we're going to be working on ionic formula writing. In order to be successful with this lecture, you need your Unit 5 book. You can specifically open up to page number 5. There's going to be notes that you can look at that I'll read in just a second. And then you'll also need your periodic table. Okay. I'm making this lecture from home, so I will give you a heads up. If my dogs bark, just know that they're also getting on my nerves too. Okay. As always, if I'm going through the video and you feel like you need to pause and write something down, or in this lecture, I'm going to be going over examples. So what maybe you should do is pause the video and you try the examples on your own when you feel comfortable, and then you can play and see if you got them right. Just make sure that you are using the lecture to your best and the best way for you to learn. Okay, so ionic compound formula writing. So if you look at page 5, and I'm not sure if your screen can see the PDF, but formula writing says naming is the trickiest part. Once you've been given the name, writing the formula is easy as long as you've memorized the formulas and charges for polyatomic ions. So in order to write the formula for an ionic compound, we're going to be using the crisscross method. So you might be asking, what is an ionic compound? So let's think about what we know from Unit 3. An ionic compound transfers electrons between atoms of different electronegativities. So those are specifically metals and nonmetals. So I want you to start getting in the habit of every time you see a name, you're looking at your periodic table and you're putting your fingers on the elements that are within the compound. That way you know if it's a metal or a nonmetal, and you know which naming system you're working within. Because if you're watching this video for ionic, that means you also know how to name organic compounds and covalent. So this is where all of our rules have to be kept separate. Okay, so ionic compounds, they can also be binary. Remember, we talked about how the word binary means two different atoms. But ionic compounds can also get particularly tricky because we're going to start seeing our polyatomic ions. So if you do not know your polyatomic ions, you are really going to start feeling panicky because you just have to know them. Okay, so ionic compounds are not necessarily always binary. We're going to start seeing atoms or molecules that have more than two atoms within them. Okay. So every single time you write the formula for an ionic compound, we're going to be using what's called the crisscross method. Okay, so in the crisscross method, you have to find the charges of the cation and anion. Okay, then we're never going to write a sign, the positive or negative sign within the we're never going to write a positive or negative sign within the molecule or within the atom. But you find the charges of the cation and anion, and then you I always say give the number to the neighbor, and I'm going to show that to you and it'll make a little bit more sense. So crisscross method, you have to use the charges for the cations and anions. You give the number of the charge to the neighbor. So first thing you have to think about are where can we find the charges? And so what I mean by charges, our fancy vocabulary word for that is oxidation numbers. Okay, so remember again, in Unit 2 and Unit 3, we discussed how the metals and nonmetals within the periodic table will gain or lose electrons in order to be stable. And so we can predict their oxidation numbers, or we can predict their charges in a predictable manner because of the periodic table. Okay, so that's your first place to look. Okay, second place to look are the charges for your polyatomic ions. Those you just have to know. So those should be memorized by now. Okay, and last you're going to see Roman numerals now. And I'll show you that in a second. So just a review for Roman numerals. 1, 2, 3. 3 are going to be in parentheses. 4 is IV. 5. VI is 6. VII is 7. That's typically as far as we'll go. One big thing that you also have to remember with the crisscross method is to reduce the subscripts when you can. So ionic formulas, the subscripts that you see at the bottom of your compounds are as reduced as possible. Okay, so here is your periodic table. We went over the oxidation numbers as you see written on your periodic table. Those you just have to know. Okay, so again, if you don't have your periodic table out, you have to keep it out because I'm not going to keep referencing this slide to help you see your oxidation numbers. So if you look at calcium, calcium is in the group where the oxidation number is a +2. If you look at bromine, bromine's in the group where the oxidation number is -1. Okay, now I want you to look at the middle of the periodic table. Okay, in the middle of the periodic table are transition metals. And so I have a big dark outline around the transition metals. And you can see that over here with tin and lead and thallium and indium, those are transition metals. They're just out of place. Okay, so from gallium up, you can predict the oxidation number to be +3. But anywhere down below it, so tin and lead, indium, all the way over to scandium over here, those are our transition metals. And you're going to start seeing Roman numerals. And the reason that happens is because our transition metals have those variable oxidation numbers. So you're not going to always know their oxidation numbers, except for the 3 that I have marked: zinc and cadmium and silver. We mentioned earlier, like I said in Unit 2, that these are the charges that these atoms always have. So you're not going to necessarily see Roman numerals for those. Okay, so don't feel overwhelmed. Just again, make sure you have your periodic table out so you can continue to reference it. Okay, so let's say that I wanted to write a chemical formula with the atoms of sodium and oxygen. We're just going to keep this simple so far. So if you find sodium, sodium's in group 1, and so therefore it has a +1 charge. So I'm just going to write the 1 up above for scratch work. Okay. If you find oxygen, oxygen's in the group where it's going to have a -2 oxidation number. So I'm going to write a 2 up above. Okay. Again, this is just scratch work. This is helping me see where my formula is coming from. So when I want to crisscross these 2 charges and make a compound, the 1 is going to come sit next to the oxygen, and the 2 is going to come sit next to the sodium. So we are literally crisscrossing the numbers. So give the number to the neighbor. So our chemical formula would be Na2O. Okay, so the correct way to write ionic formulas is we use subscripts. So I have the scratch work for the charges up top just so that I can see what I'm doing, but then the actual answer, I have subscripts. Okay, so let's look at calcium and nitrogen. Okay, calcium's in the group where it's going to have a +2 charge. So I'm going to write a little 2 up top to help me out. Nitrogen is in the group. Put your finger on it. It's in the group where it's going to have a -3 charge. Okay. So that means when I crisscross, the 2 is going to come to the nitrogen. The 3 is going to come to the calcium. And so my formula would be Ca3N2. Okay. So if you look at the 2 formulas that we've written, 3 and 2 cannot reduce any further. I have 2 and 1. It can't reduce any further. So these formulas are finished incorrect. Okay. So now let's look at magnesium and sulfur. Magnesium's in the group where it's going to have a +2 charge. Sulfur's in the group where it's going to have a -2 charge. So you can see right off the bat that 2 and 2 would cancel. So instead of writing Mg2S2, that further reduces to MgS. So here is our final answer. Because ionic compounds, you have to reduce the subscripts. Okay? So lithium and bromine. You guys look up lithium. Again, if I'm going too fast because you are needing to look for your atoms, just pause me. Make sure that you are finding everything on your own. So Li is lithium. It's going to have a positive 1 charge. Br is bromine. It's going to have a negative 1 charge. So you can see right there, LiBr is going to be our formula. Okay. AlCl, aluminum's in group 3. Chlorine's in as a halogen, so its oxidation number is going to be -1. So my chemical formula, the 1 goes to aluminum. I don't write 1s in chemistry. The 3 comes to chlorine. And there's our formula. Okay. So the bad news is, maybe it's not bad news. I just did these examples right off the bat so that you can see the general method. Now, on my next couple of examples, you're going to have words, okay? So, for instance, potassium iodide. So, this is where we're going to have to really hunt and peck, okay? So, if you find potassium symbol is a K, and we know that its oxidation number is a +1, okay? Iodide. That sounds like iodine. Remember in covalent nomenclature, we changed the ending to IDE. In our next lecture where you learn how to name ionic compounds, you'll see, we'll talk about endings. So iodide is iodine, so that's going to be an I. And it also has a 1 as a charge. So K1I1, the chemical formula for potassium iodide is going to be Ki, capital K, capital I. Okay, magnesium oxide. So if I find magnesium symbol is Mg. Its oxidation number is 2. Oxide is going to be oxygen. Its oxidation number is a -2. So 2 and 2, hopefully you recognize that that will reduce, MgO. All right, gallium nitride. We'll flip back and look at the periodic table for that one so that you are 100% sure where the charges are coming from. So gallium nitride. So if I look at gallium's in the group where it's going to have a +3 charge. Nitrogen's in the group where it's going to have a -3 charge. Okay. So Ga3N3 is going to be GAN. So you can see when, hopefully you're starting to see when the subscripts are going to reduce. And that's because it's kind of like, think about fractions. I know you probably don't like fractions from math class, but that's a really good way to think about it. Okay, so some examples with transition metals. So I've already mentioned transition metals have a variable oxidation number. And so the actual chemical name will tell you the oxidation number. And you're always going to see it in parentheses as Roman numerals. Now, I know that I've already mentioned that we don't write 1s in chemistry, but obviously if you look here at copper 1 oxide, we do have to write the 1 when you have a 1 as an oxidation number for a transition metal. Okay, and you'll see in the next lecture of how to find the Roman numerals. So that's for a completely different lecture. So chromium 3 chloride. Hunt and peck for chromium. As you're hunting and pecking, you'll find that the symbol is Cr. It's in the middle of the periodic table. And so therefore this 3 is telling us that it's a +3 oxidation number. Okay, metals, as you should know from Unit 2 and Unit 3, always have positive oxidation numbers. Okay, so Cr3, chloride, the symbol is going to be Cl, and the oxidation number is a 1, a -1. So when we crisscross our formula is going to be CrCl3. All right. If you want to pause and try the next examples all on your own, I think that that's a great thing for you to do. Start trying to help yourself learn as you go. Okay, so chromium 3 chloride, or sorry, copper 1 oxide. So copper is Cu. It has a 1 oxidation number here. Oxide is oxygen. It's going to have a 2 as an oxidation number. So our chemical formula is going to be Cu2O. All right, manganese 2 phosphide. Notice magnesium, manganese. They are two completely different atoms, okay, two elements. So the symbol for manganese is Mn. It's telling me the oxidation number is a positive 2 here. Phosphide is going to be phosphorus. And if you look at the symbol for phosphorus, it's going to have a negative 3 charge. So my formula would be Mn3P2. All right, silver bromide. So if you look, Hunt and Peck, find the symbol for silver, you'll find that it's Ag, and you might be grouchy because there aren't Roman numerals there for you, but hopefully on your periodic table, you mark that silver's charge is always a positive 1. So if you're not given the Roman numerals for silver, it's because it's assuming you are a chemist and you know that. So bromine is going to be Br with a 1. So my formula is AgBr. Okay. Lead IV oxide. So you're probably going to have to hunt and peck for lead. Lead symbol is Pb. And now this Roman numeral is 4. So I have lead with a positive 4 charge. Okay. Oxide is oxygen. So there's O. And it's always going to have a 2 as the charge. So if you write Pb2O4, hopefully you register that this 2 and 4 can reduce to PbO2. Okay, so far, all of the ionic compounds we have worked with have been binary. So again, that means that there are 2 different atoms. Okay, and again, specifically, these atoms today are metals and nonmetals, okay? And I hope maybe you started to notice that the metal or the cation always comes first. The anion always comes second. So I think the easiest thing for chemical nomenclature is to start recognizing patterns. So those are 2 big patterns to recognize. Now, again, if you don't know your polyatomic ions, you are really going to be sad, okay? So ionic compounds with polyatomic ions, you have to have the charges memorized, okay? Those charges will never change, but you'll see in the next lecture that the endings of our polyatomic ions are going to start changing a little bit, okay? So we still use the same exact method, the crisscross method, but now we have groups, okay? All of your polyatomic ions are groups of nonmetals. So sodium has a 1 as an oxidation number, and you should know from your brain that this whole entire group of nitrate has a charge of -1, okay? So that means when we go to write our chemical formula, I'm just going to smush those 2 things together. NaNO3, okay? So you can see that I have 1 sodium and 1 nitrate, okay? But we just don't write the 1. So the correct formula again is NaNO3. So calcium has a positive 2 charge. Nitrate has a 1 charge. So when I crisscross, the 1 is going to come to the calcium, but this 2 means that I'm going to need to have 2 nitrates. So we're not going to start changing the subscripts on our polyatomic ions at all. What we're going to do instead is put these polyatomic ions in parentheses so that we can represent that we have 2 of them. So the correct way to write this is Ca parenthesis NO3 parenthesis 2. So again, this 2 is distributed to everything within the parentheses, and only the parentheses. It tells us where to stop, okay? So I usually tell my students that if you want to put parentheses around every polyatomic ion that you come across, that's fine, but you don't have to. So let's say that we need, what if we work with ammonium, NH4? Okay, that's one of our polyatomic ions. I know its charge is a positive one. What if we do acetate, C2H3O2 with 1. 1 is a charge. So the 1 and 1 would cancel, and so I would just write both of those pieces together. Okay, again, I knew all of those formulas because I have them memorized. Okay, what if I have ammonium with, let's do, trying to think of different, sulfate, phosphate, carbonate. Let's just do phosphate. NH4, PO4, 3. So you could technically write this in both sets of polyatomic ions in parentheses, but technically I'm just going to need 3 of these ammoniums, so I put it in parentheses. So NH4, 3, PO4. Okay, so again, we only have parentheses around polyatomics in formulas. Okay, and that's because when you start changing the subscripts on your polyatomic ions, you're actually changing the name of them. Okay, so let's try a couple for practice. So potassium sulfate, potassium is K, has an oxidation number of +1. Sulfate is not sulfur. You should just be able to recognize the name sulfate. So sulfate is SO4 with a -2 charge. So remember, I'm not writing the positive and negative signs just because when we write formulas, the positive and negative signs don't appear. So when I crisscross, the 2 comes to K, so K2SO4. So I have 2 potassiums and I have 1 of my sulfates. Okay, but remember, we don't write 1s, and you don't have to use parentheses around your polyatomic ions all the time. I'm just trying to help you visualize what I'm doing. So manganese 2 hydroxide. Mn is manganese. I have a +2 as an oxidation number. Hydroxide, you just have to know, OH with a -1 charge. So my formula is going to be MnOH2. Okay, aluminum phosphate. I have Al +3, PO4 -3. Sorry, I wrote that positive. Have it. Again, if I'm going too fast, y'all, pause me and you try on your own. So hopefully you recognize that these 3s would just cancel each other out and we would write AlPO4. Okay, 10 IV carbonate. We'll probably have to hunt and peck for 10. We haven't used it yet. So that's SN. This IV is telling us that it has a +4 charge. Carbonate, CO3 with a 2 charge. So we would have SN2, CO3, 4. And so when it comes to reducing the subscripts, these are the 2 I'm looking at. Because if you change the 3 on carbonate, you're not working with carbonate anymore. So the actual chemical formula is going to be SnCO3, 2. Okay, I have a couple more of just all that we've done today wrapped into one. So if you want to pause and try all of these on your own, you can, but you don't have to. You can just work them with me if you want. So cesium bromide. Cesium is CS, has a +1 charge. Bromine is Br. Br, it has a -1 charge. So my chemical formula is going to be CSBr. Sorry, that B looks bad. CSBr. Okay. Barium sulfate. Barium is Ba with a 2. Sulfate is SO4 with a 2 as well. So I would have BaSO4. Cobalt 3 nitrate. So cobalt is CO. It has a 3 from our oxidation number, our Roman numerals. Nitrate is one you have to know from your brain, NO3 with a 1 charge. So my formula is CO, parenthesis, NO3, 3. Okay. Potassium chlorate. Potassium is K with a 1. Chlorate is ClO3 with a 1. So my chemical formula is KClO3. Lead IV sulfide, so Pb with a 4. Sulfur is a 2, so Pb2S4. Hopefully you recognize that we need to reduce that. PbS2. And zinc arsenide. So zinc, if you put your finger on zinc, the symbol is Zn. It's a transition metal. It didn't give us Roman numerals, so that means that you should know the charge. So Zn with a 2. Arsenide, we'll have to look for. We haven't used it yet. Arsenide is As, and it has a -3 oxidation number. So As3. So my formula would be Zn3As2. Okay, so as you've gone through this lecture, I hope that you've started picking up on patterns. And just remember that we have now learned how to name organic, covalent, and ionic. So this lecture focused on writing formulas for ionics only. There's going to be another lecture for naming ionic compounds. And so it's really, really important that you start keeping all of your rules separate from one another. So in your unit book, on page 6, there's a giant chart where you can just crisscross your charges in the box. You don't have to do that, but if you feel like you need more practice crisscrossing, you have that available. I would definitely look at page 7, okay? Because on page 7, there are, you are given the name and you write the chemical formula. And I think there's also more. Yeah, so even on page 11, like you can do the bottom of page 11, 11 through 20. Page 11, 11 through 20. If you need even more practice with crisscrossing and writing formulas for ionic compounds. So thank you for watching. Please go back and rewatch anything that will help you out. And as always, ask your chemistry teacher for help if you need it. Thank you.